Hello everyone, my name is Youwei Jia from Southern University of Science and Technology. In this presentation, I'd like to talk about a novel retrospect-inspired regime for microgrid real-time energy scheduling with heterogeneous sources. In small-scale microgrid operation, the uncertainty issues associated with the renewables and low demand become much more evident, which make energy scheduling even more challenging. This figure presents a typical small-scale microgrid, which comprises of multiple dispatchable units and non-dispatchable sources. So here, we consider the real-time energy scheduling problem on these dispatchable units, which can be mathematically formulated as a receding horizon optimization problem. The objective is to minimize the total operational costs incurred by local generators and the deficit electricity purchased from the main grid. This is a typical modeling why it can be less effective in this particular circumstance. Firstly, all the decision variables are across time coupled and can be greatly influenced by the concerned locale window. And this problem is NP complete. Furthermore, since the decision makings greatly rely on future information, MPC may be less effective if the prediction accuracy is unsatisfactory. So in our study, to overcome these limitations, we aim to establish an operating regime which has prediction oblivious features. That way, the effectiveness of this regime should be less dependent on the future information. In addition, this regime can be easily implemented for real-time energy scheduling. In our study, we propose a new algorithm named as HCHASE, which is capable of handling multiple heterogeneous generators in microgrid. Here, the heterogeneity indicates various startup cost levels of schedulable units. This flowchart presents the essential process of HCHASE algorithm. I'd like to clarify that HCHASE is a general extension of chase algorithm. Interesting audience can refer to the first paper right here. The general idea behind chase algorithm is to handle energy scheduling problem in real time by simply determining the opportunity cost in switching on or off the local generators and make decisions that are close to global optimal. While chase can only handle homogeneous generators, and the newly proposed HChase becomes much more general in handling multiple heterogeneous local generators with different startup costs. The effectiveness of this regime relies on two important theorems. The first one confers the optimality of RHOP decomposition, in which the net load can be partitioned into different levels dedicating to specific generators. Theorem 2 gives a direct solution to the competitive ratio of HChase. In the sub-RHOP, decision makings can be obtained based on basic chase or its extension, for example, iChase or rChase. Regarding these algorithms, you can refer to these two papers for more technical details. So here, I would like to show you some experimental results. We test HChase and the MPC on a laboratory scale microgrid. As we can see here, we compare MPC and the HChase in three typical scenarios. The left one shows the case with limited accurate forecast information. The on-off actions of HChase closely lag behind the optimal solution yielded by perfect dispatch, while MPC fails to turn on the local generator in due course. The middle one shows the case that the lookout window is sufficiently long and the forecasting accuracy is high. MPC provides better scheduling performance than HChase, but both of them obtain very small competitive ratio. The right one shows the case that the lookout window is sufficiently long for MPC, while the forecasting information is less accurate. Then HChase exhibit better performance than MPC. So here we can easily conclude that HChase-based scheduling regime is much more robust to uncertainties. In conclusion, we propose HChase scheduling regime which relies on zero or little forecast information. H-chase is a general extension of chase algorithm, which can handle heterogeneous generators. In the cases with high operational uncertainties, H-chase outperforms MPC. And future work will focus on standalone microgrid, in which the energy storage system should be properly considered and economically scheduled in real time. Okay, that's all about this presentation. Thank you so much. If you have any question, please feel free to email me.